Modeling with quadratic functions. So here they're telling us we have a parabola, and the parabola is going through the points 0, 0, -1, -2, and 1, 6. They're looking for the equation of this parabola in standard form. So remember, in standard form, we're talking about y equals ax squared plus bx plus c. All right, so that's our standard form. So we need to come up with an equation in that format for a parabola that's going through these points. So what we'll do is we'll go to the calculator and we're going to get a list and spreadsheet page. So up top, we'll label the columns X and Y. This is going to be very much like we did for linear regression, except really this time we're going to do a quadratic regression. Okay, so the X values for ordered pairs were 0, -1, and 1. And then our Y coordinates were 0, -2, and 6. All right, so we have the data entered. We're going to get a calculator page now. And if you recall, the keystrokes for the linear regression were menu, statistics, stat calculation. So we're all the same up to that point. But rather than choosing a linear regression, we're going to choose a quadratic regression. Same screen comes up where they ask for the column headings. So we're going to enter those. And then tab down to OK. So now it brings us to a screen, just like when we did the linear regression, it showed us what the slope and the y-intercept were. Here they're showing us the values for A, B, and C. All right, so we have A is 2, B is 4, C is 1.33 times 10 to the -13th. Let's write those down on our paper. So A was equal to 2, B was equal to 4, C was equal to 1.33 times 10 to the -13th power. All right, so we have so far y equals 2x squared plus 4x. Let's take a look at C for a second. If we're in scientific notation, at 13 decimal places, that means okay, here we go. So if I have an exponent of -13, that means I need to move the decimal point 13 units to the left. So now my decimal point is here to get the actual number. So when I look at this number, if I had to round it, it would round to 0, nothing else. So I could put plus 0 here, but 2x squared plus 4x plus 0 is just 2x squared plus 4x. So my equation then will be 2x squared plus 4x, and there's my equation in standard form. So again, very much like doing the linear regression, except we're doing a quadratic regression. Same idea here. They have a parabola that's going through the points 0, 0, 1, -2, and -1, -4. So they want the equation. We'll do a quadratic regression, and we'll come up with the equation. So let's get rid of this. Okay, so we'll start again, labeling the columns, X and Y. So our X coordinates were 0, 1, and -1. And our Y coordinates are 0, -2, and -4. Okay, we have the data entered. We'll get a calculator screen. Same keystrokes. So menu, statistics, stat calculations. We want the quadratic regression. We'll enter our column headings. Click OK. And we have our values for A, B, and C. So we'll copy these down. So we have A is -3, B is 1, C is -2 times 10 to the -13th power. Okay, yep, -3, 1, -2 times 10 to the -13th power. Okay, so if the standard form of the equation is ax squared plus bx plus c, replacing those values, we have -3x squared plus x. Now for the -2 times 10 to the -13th power, again, we have a situation like in the previous slide where this is going to amount to 0 again. And since c is 0 for all intents and purposes, we don't need to write that into the equation. So our equation is y equals -3x squared plus x. All right, here they're showing us a table of a meteorologist's predicted temperatures for an October day in Sacramento, California. They want the quadratic model for this data. So again, we can do a quadratic regression. There's just one thing we have to take a look at here. We are starting at 8 a.m. to 10 a.m. to 12 p.m. Now we have 2 p.m., 4 p.m., and 6 p.m. If we were to enter these numbers the way that we see them here, it's going to throw off the model. To keep it consistent, we should have military time. So for example, 2 p.m. would be 14, 4 p.m. would be 16, and 6 p.m. would be 18, right? Military time, we just have to add 12 to whatever the time is, and 2 p.m. plus 12 is 14. 4 p.m. plus 12 is 16, and 6 p.m. plus 12 is 18. Now when we enter the data, we'll have something that actually means something. So let's go to the calculator and enter the data. So again, label your columns. All right, so we had 8, 10, 12, 14, 16, and 18. For the temperatures, 52, 64, 72, 78, 81, and 76. All right, so to get the quadratic model, we're going to go back to the calculator screen, and it's menu, statistics, stat calculations. We want the quadratic regression, column labels, and here we have it. So let's write down A, B, and C. So A is equal to -0.46875. B is equal to 14.71607. Remember, when you're doing these, you want to go about 4 or 5 decimal places at least to get an accurate model. And C is equal to 36.124312143. Okay. So our model then would be negative 0.46875 x squared plus 14.71607 x, and this was a negative 36.12143. All right, so there's our model. In part B, they want us to use the model to predict the high temperature for the day and at what time does it occur. All right, so to get the high temperature, we need to graph this and find the maximum, and that will give us the information that we're looking for. So again, we'll go to the graph, to the calculator rather. And graph this. So negative 0.46875 x squared plus 14.71607 x and negative 36.12143. Okay. All right, so we're going to have to adjust the window here. We could try a zoom fit. And we're just about there. We're going to have to zoom out a little bit. And now we can see the vertex, so we're good. Let's get the vertex. Remember, it's menu, analyze graph. We have a maximum here because the vertex is at the top. We need a lower bound, so we want to be to the left of the vertex, and upper bound to the right of the vertex, and those are the coordinates for the vertex. So they wanted to know what the high temperature was for the day. The prediction for the high temperature would be 79.4 degrees. Okay, so the temperature, 79.4 degrees. And it says at what time of day does this occur? So that's going to be the X value that we have here. So 15.7. So 15 is 3 o'clock, 0.7, almost 3/4 of an hour. So we can approximate it at about 3:45 p.m. is when that high temperature occurs. Okay, so one more thing. They show us here that campers at an airspace camp launch rockets on the last day of camp. The path of rocket 1 is modeled by this equation. Okay, so that's rocket 1. T is time in seconds. H is the distance from the ground. So H would be the height. The path of rocket 2, shown in the graph at the right. Okay, so here's rocket 2. Which rocket flew higher? All right, so we have the graph of rocket 2 here in front of us, and if we took a look at the vertex here, we could say that the highest point is at about 575. So at about 575. The height for rocket 1 we can get if we graph the equation that they gave us. Now in the calculator, we're not going to be able to use H and T but h would be equivalent to y in this case, and t would be equivalent to x. So we'll use that. We'll use y equals negative 16x squared plus 150x plus 1 to find the height of this rocket. Okay, so we have negative 16x squared plus 150x plus 1. All right, so again, we have to adjust the window so we can see the vertex. So we'll do a window zoom. We'll try a zoom fit. Perfect. And we have the vertex here, and we just need to find the maximum height. So menu, analyze graph. It is a maximum. So a lower bound to the left of the vertex, upper bound to the right. And what does it tell us? So the maximum height is going to be the y coordinate, so at about 353 feet. So for rocket 1, we have approximately 353 feet. For rocket 2, approximately 575. So the rocket that flew higher, we'd have to say rocket number 2.